Welcome everybody. In this session, we're delighted to talk about how to develop a cross-platform apps. We're hopefully to make things easier for developers and introducing the standardized framework that you can deploy your app across different headsets or different platforms. Okay, so I'm Jane. I'm from Pico. I'm the product manager from Pico OS. I'm really delighted to share some experience and our lessons learned for developers. Now let's get over to my colleague, Jimmy.
Hi, my name is Jimmy Allen Permble. I work in the Developer Technology Engineering Group at Pico. I'm also a dad of 2 kids who used to think my dad jokes were lame. But nowadays, they have grown on them. Sorry.
And,
on to Joe.
Sorry, Jimmy. Yeah, and I'm Joe from GreenSky Games, and I just got in 24 hours of travel, so if I mumble a little bit, that's why. Thanks for having me.
Yeah, so glad to have product team, the engineering team, and our delighted partnership team from GreenSky to share some experience. Okay.
Doesn't seem to advance. Ah, there.
Okay, just to get started, let's look at how we develop an app at the moment. Before OpenXR, developer need to use the SDK provided by the platform, using the SDK to write specifically for that platform. So if you want to deploy your app into a different headset, you have to rewrite the whole thing. You have to rewrite the code. It's a lot of effort. Now we have OpenXR. So the good thing about OpenXR is it provides a standardized API. So for example, if you are a headset developer, you can automatically get access to some basic VR features out of the box. You just need to write up to the OpenXR API and use the native OpenXR SDK. One example is YouTube VR. YouTube VR has published across different headsets. So the good thing about it is with OpenXR SDK, you can access really high-speed processing within the app. However, there's still a disadvantage for that. As you know, that writing up to OpenXR API still needs a lot of work, and it's just way difficult compared with using the engine. So let's introduce another way, which is using the engine. Well, engine make it easier. You can just access to the OpenXR APIs, access to the functionalities provided by the engine SDK. Both Unity and Unreal provides engine OpenXR SDKs. So maybe we can introduce Joe to give us some example of how he used the engine to develop a cross-headset app.
Awesome, thanks, Jane. So again, I'm Joe, founder of GreenSky Games. We have a few titles out. Swarm 1, which is the top action-rated title on Quest, and Swarm 2, which was the NYX Arcade Game of the Year this year. And I just want to tell you a little bit about how we use the Pico OpenXR plugin to get Swarm 2 ported to both Pico and a few other platforms. And so let's talk about context. So Swarm 1, I don't know if any of you know it, but it's a grappling game. It's an experience that could only happen in VR, and it's fundamentally built around this grappling movement where you kind of feel like Spider-Man with guns. And when we started Swarm 2 development, we were starting from Swarm 1 code. And when we ported Swarm 1, it was entirely built around the Oculus SDK. And there were dependencies, so many dependencies on that SDK, that in order to port it, we actually had to rewrite all of the XR code, all of the hand tracking, all of the headset tracking. And it was so much work that we actually had to hire an external agency to do that work for us. Each port would take about 3 months and cost tens of thousands of dollars. And I think now maybe the cheapest rate you can get on a similar port is around 40,000 US from a Brazilian studio. But it was a lot of work. And so with Swarm 2, we wanted to take a different approach. And so we got the OpenXR plugin from Jane and the Pico team. And we wanted to build a platform-agnostic system that would allow us to get Swarm 2 on a bunch of different platforms. Now, the issue was that we had started from Swarm 1 code, so we had these dependencies. So step 1 was refactor the code so we could get rid of the dependencies. And great. Now OpenXR handled all the XR input across all platforms, which was fantastic. Step 2 was we had to build a platform adapter. So different platforms have platform-specific features like friends, achievements, leaderboards, and we wanted to abstract away from any platform-specific implementations. And so the platform adapter, we could call it without using any specific code for that platform, and the platform adapter would figure out what platform we're on and what do we want to do. So for example, leaderboards, which is platform-specific, we could call leaderboards, and it would return leaderboard data that we could then display, but we wouldn't have to care about where the avatar image is stored, or where or how are the usernames formatted. It would just handle all of it for us. So in doing this, we really reduced the amount of both development time, but also QA time that we needed to do this. And we learned some things along the way. So the platform adapter, when you're building it, you really have to make sure that it supports all features for all platforms. So for instance, Quest might have 120 hertz mode that other platforms might not have, and it has to support all of them. And so what do we wish we did differently when we started, right? That's what we're here to sort of tell you about, is really just that we wish we started with OpenXR. Now all of our projects, we've got 3 unannounced titles, actually start with OpenXR so we can be platform agnostic, and it saved us about 3 months of work with 2 devs for each of those platforms. So I really believe that OpenXR is the way to go. Back to you, Jane.
Thank you, Joe. That was a great use case. So just like we said, using the engine OpenXR plugin makes things way easier because you can just build once and you can easily deploy across different platforms easily. So we talk about using the OpenXR native implementation. Now we also talk about Unity and Unreal. They both offer the official engine OpenXR plugin, and we really encourage developers to actually try use those. And besides using right up to the engine SDK, actually there's even easier way because engines, they usually provide some standardized tools. For example, some standardized toolkits that you can easily just check or uncheck the features, the platform, that you can just enable the basic features. So speaking of the standardized abstraction tools, Jimmy, would you like to share some experience?
Sure. So Joe spoke about how you could basically just use OpenXR plugin and provide some platform abstractions on top of that to help get all your apps across multiple headsets. Now, is there, I think what we kind of think about is there a better option than having to create all these platform abstractions for all these features? And I think the answer is basically yes, because some of the things that Unity provides, for example, are like these higher level abstractions on top of the plugins, including things like XR Interaction Toolkit, XR Hands, and both of those for input, as well as AR Foundation for more of the MR kind of features, like anchors or meshing, etc. So if you wanted to use XR Interaction Toolkit, it provides like cross-platform XR input abstraction. So whether you have controllers or you have your hands or you're using touch controls on mobile, those are all like abstracted away, and you can basically just use them independently. And you basically just create an interactor, and that'll allow you to just create an app that interacts with your XR world, if you will. And then you can also create interactables in the world, that'll help you to do things like basic object hover, select, grab, that kind of stuff. And it'll also give you visual feedback of all your interactions. And it also allows you to give sort of standard UIs that you could provide out of the box. And it'll help you make a lot of progress with very little effort because you already have all these tools provided for you. In addition to that, there's also, as I mentioned, AR Foundation. So AR Foundation is kind of like an abstraction over the MR features, things like anchors, meshing, body tracking, and so on. Some headsets provide this AR Foundation abstractions and integration. And if you're using those headsets, then you can basically just write to this one API and or this one abstraction rather, and basically have it work across all your headsets. So I mentioned AR Foundation, and I'm guessing that some people's ears picked up because I'm curious, how many mobile XR developers are here? By raising hands?
Yeah, there are
Yeah.
quite a few.
Yeah. And how many of you have heard of AR Foundation? Yeah, I guess the same people. So mobile XR has essentially a lot of apps that are using AR Foundation. So this is a common theme among mobile XR. Joe, I'm curious, if you were to handle a mobile XR app, how would you go about doing that?
Yeah, I mean, I think our main takeaway from porting Swarm 1, paying all that money, taking all that time, and then using the OpenXR plugin for Swarm 2 is that a higher level abstraction just saves a ton of time. So we'd want to do something similar.
Yeah, I mean, I guess that's what we're kind of saying. Like, you should consider porting your mobile XR apps over to headset because it's way simpler. If you're already using AR Foundation, for example, it'll just translate right across. You don't have to do anything at all. If you're using XR Interaction Toolkit, that's great. But even if you're not, it's easy enough to use XR Interaction Toolkit to provide some of the more input management kind of functionality. So all in all, it's way easier to convert to mobile, convert from mobile to XR if you already have these higher level abstractions that you're using. You might need some adjustments to your UI, etc. But for the most part, it should just come across. So
Jimmy, I've got a question here. What different platforms does this support, and how would you actually enable it?
Yes, so if the way you enable it is basically through XR plugin management. Good question, by the way, Joe. So basically, XR plugin management allows you to look at the different support you have for different hardware, including AR Core on mobile, and for example, if you have Pico or other headset platforms, you can select it in your XR plugin management. So in this case, for example, if you had a mobile app that used AR Core, you could just check the Pico checkbox there, and you now have support for Pico headsets, and you could just build your app onto Pico. For the most part, with very little change. In the Pico plugin settings at the bottom there, you have the selection for AR Foundation support and the particular features of AR Foundation that we're supporting through Pico. So that's kind of like pretty easy in the dialog box. In addition to that, basically what we looked at was how do we actually try and bring some of these AR Foundation apps across to Pico. So we looked at the AR Foundation samples, and we kind of considered how easy would it be to just bring across these AR Foundation samples to headset, like from a mobile to headset, how easy would it be? So one of the features that we have that supports AR Foundation is a body tracker. So this is a separate hardware that we provide, and it basically sits on your arms and legs and allows you to track your body. Now, AR Foundation has a sample that only works on ARKit that uses the ARKit body tracking example. Now, we just took that same scene, brought it over to the headset, and all we had to do was change some settings, especially the bone controller, because we have slightly different bones from what ARKit provides. And we were able to just make it work with very little changes. I mean, basically no code changes at all, just some config changes and settings changes, essentially. So this is kind of like our that AR Foundation sample in action once we've moved it over to headset.
Yeah, I want to add one more point. The good thing about this is potentially a lot of developer or a lot of headset platform, they provide different hardwares. If you are a developer, you have to rewrite your code to actually adapt to a new tracker. However, if we enable in the AR Foundation, you just need to check the body tracker and then check the target platform like Pico, then you will automatically fit for your targeted devices. So quite convenient.
Another example was the anchors. So AR Foundation Samples already has an anchor tracking example. Anchors are basically just things that you can basically place in the world, and they will maintain their position as you move around. So we took that mobile AR Foundation sample, and then we just changed the input mode of it so that we could just put place trackers with the controller. So we basically had one extra editor script that basically allowed you to place anchors using the controller. And doing that, basically, that was the only change we made for this particular sample. And we were able to do basically creating anchors in your room, essentially, using our headset and the controllers.
Yeah, as you guys can see, like we added some Pico premium features like create anchor, delete memories, all the options you can all enable through AR Foundation.
And finally, we had a sample for meshing. So this one, again, translated pretty much with no code changes, and actually just all we had to do was put in some configs for our meshing subsystem. So all these are basically XR subsystems that AR Foundation supports. So we just provide implementations for those. And so in this sample, we had very little changes. In fact, we didn't even change the texture and the, we didn't change the shaders that were used on the mesh, so it doesn't look great, but we just wanted to prove a point that we had very little changes that we needed to do to basically show off basically this mobile sample coming across the headset. Now, these samples should work on every headset that also supports AR Foundation. So that's kind of like, I guess, the extent of all the different samples that we have that we can show. But we basically have an SDK coming out that supports AR Foundation with Pico. Do you want to speak a bit more about that?
Sure. Thank you, Jimmy, for the detailed explanation. As you can see, that enabling some higher level abstraction tools is quite easy. So just a quick summarize, we've talked about how to develop across different headsets. You can use the OpenXR native SDK. You can use the engine OpenXR SDK. Or if you want to make it even easier to develop from a mobile platform over to a headset, you can actually use the Unity's standardized framework like XR Interaction Toolkits, XR Hands, or the AR Foundation. So as Jimmy just explained, it's super easy. You just go to the setting, check the target platform like Pico, and then you just check each feature. Then you can enable that on our target platform. So all you can do, for example, if you're targeting Pico platform, just go to our developer website, download the Pico Unity OpenXR plugin or the Unreal OpenXR plugin, then it will automatically work. So with the upcoming Pico 4 Ultra launch, we are delighted to announce that we support fully engine OpenXR plugin for both Unity and Unreal. Also, we will be fully support the latest version of AR Foundation, XRI, and XR Hands. So you can experience all the latest feature provided by the official engine platform, all enabled on our platform. So hopefully you guys will give it a try and make your life easier.
Yeah, and the other thing, there's the added advantage of bringing over mobile XR apps very easily over to headsets. So I think we should not discount that factor. I think it's a very important factor. I think a lot of mobile XR developers are interested in going over to headset, and this would be kind of like a good way to start doing that.
Yeah, Joe, what do you think? If you can just develop once and you can deploy on different platforms, that will make way more traffic and revenue.
Way easier, yeah. I could have saved a lot of headaches.
Time and money.
Yeah.
Okay. Hope this session will find helpful for you guys. And thank you so much for attending this session.
Yep.
Thank you.
Thanks, everyone.
Thanks.